See, actually, I just wanted to give you an outline. We are about to complete this chapter. There will be four more subtopics left out, right? So, the first thing we saw is about a point charge. So, what is the force? Who tells us about the force acting between point charges? Which law spoke about it? Coulomb's law, right? After Coulomb's law, we saw what happens with respect to point charge and what is the value of electric field created due to it. Then we saw 2 point charges which are in the form of a dipole, right? Till now, all that we were discussing is only about point charge. The question is the system, the world need not have point charge everywhere. What if you have extended charges, right? So if you have an extended charge like something like linear charge distribution, surface charge distribution and volume charge distribution, if you have something like this, then how are you going to define the charges for it? That is the first thing we are going to understand from this topic. After that, we saw the concept of electric flux, no? That electric flux relates to the concept of something called as Gauss law. So there are two laws in this chapter. One is Coulomb's law and the second is Gauss law. So Coulomb's law is applicable only where you have point charges. Whereas Gauss law can be applied whether you have a point charge or a extended charge. So what do I mean by extended charges? If the size of the particle cannot be ignored. So this will actually simplify your job. You can ask me a question. Sir, if the point charge is not there, suppose I have this pen which is completely charged. If I'm interested to calculate the electric field due to this at a particular point, but I want to use only Coulomb's law. Am I allowed to use it? Yes, you are allowed to use. The only challenge is you have to break the system into multiple point charges, infinite number of point charges, take dq and due to the dq find the electric field and then integrate, which is a tedious process, which is not a part of your syllabus for CBSE as well. For competitive exams, we do it, right? For CBSE, it's not there. To simplify that job, what they have done is this Gauss law is there. And this Gauss law has three applications for an infinite long straight charged wire, infinite plane sheet, and uniformly charged spherical shell. With that, this chapter is done. But for you to understand the derivations for this, right, you need to understand the concept of this charge distribution. You're able to understand why it is important, right? So I need to focus on this. So what does a charge distribution speak about? As the name suggests, right, you have a linear charge distribution, you have surface and you have volume. Meaning, if suppose I have a system like this, right, where I ignore the thickness of it. If I take this and rub it against the surface, what can happen is due to frictional electricity, this material will get charged. Meaning, there is going to be charge that will sit on the surface of this conductor or whatever material it is, surface of this material. So how is the charge getting distributed? It's getting distributed along a straight line. So if at all you have a system which is just a straight line on top of which you have charges that are distributed like this, then you call this kind of a system as a linear charge distribution. And for a linear charge distribution, what we do is, if suppose I know the length of this material, which I take it to be capital L, and I add, see, these are all small point charges. They get summed up to give you a total charge capital Q. So if I am able to calculate the total charge Q and divide it with L, right, then this is given a name called as lambda, where this lambda is called as linear charge density. So till now, whenever we speak about density, right, what is that will come to your mind? Density is always mass per volume. Actually, if I have to be more specific, what they speak about there is, it's called volume mass density. Meaning, if I take a three-dimensional shape, where is the mass distributed? Over the volume. But what if you take a two-dimensional shape? I'll tell you a simple example. Both are using Classmeter, almost similar. Okay, show. How many of you have printer at home? Everybody, right? Everybody has a printer. Have you ever gone to a shop and bought a paper bundle? What is the top cover? Color? Mostly red than one brand, they'll keep giving it to you. But have you ever, as a science student, asked a question of Did the shopkeeper ever ask you a question of what is the GSM you're looking for? Has anyone asked you? Or have you ever asked or wondered what that number is? No, right? When you go and buy a paper, right, there are different kinds of GSM. For example, they call it as 70, 60, 120, 130, 170. There are GSMs like that. Any idea about what the GSM? Can you guess what that would be? What is it? Very good. It's called grams per square meter. So what shape does a paper take? Rectangle. For a rectangle, what is the parameter you can define? Will you define length, area, or volume? You will define, no, you will define area. In terms of where will the mass mass get distributed? It's on the area, right? Meaning, if you take that paper, no, if you take 1 meter square of that paper, meaning 1 meter into 1 meter, if you take 1 meter square of that paper, you have these paper particles put together, right? All the paper particles put together will be of 70 grams. That is the meaning of 70 GSM, grams per square meter. Do you know that your dress has GSMs? The cloth that you buy has GSMs. The T-shirt which you buy, when you go for a manufacturing thing, you need to ask what are the GSM that you need to have so that you can print this content on top of it. So why I'm stressing on this point is so that you will create relation between what I'm trying to say. Only difference is here grams, mass should be replaced with charge. That's it. It's not a very big concept. Okay. So if I take this water bottle, in this water is filled, no. What shape is the water taking? Like what is the physical quantity it is occupying? Is it occupying the length, area, or volume? Volume. So what is the density of the material you define inside? For a liquid, you always define volume mass density. Whereas for a paper and no, the T-shirts and everything that I told you, what do you measure? You measure areal mass density or surface mass density. Similarly, if you talk about a wire, just take a thin wire. For the thin wire, you have mass on top of it, right? You define something called as linear mass density. So if you replace that mass with charge, right, that's what we are speaking about. So those particles, instead of being small particles with mass, if they were small particles with charge, then this is what happens. It's only for linear. It's only for straight line. It's lambda. For this, I'll come. Similarly, if I take a paper, something similar to the GSM which I spoke, right? So on this paper, if you distribute the charge, meaning if I start distributing the charge like this, right? If I'm able to calculate this total area, let's say the area comes out to be A, and if I'm able to calculate the total charge, if I find the amount of charge per unit area, I repeat it. See, it's how will you put it in words? How will you define this? You should not say Q divided by L or ratio of Q and L. You should not define it like that. I told you already. Whatever comes in the denominator should be given a prefix per unit. So this is the amount of charge per unit length. This is the amount of charge per unit area. So this is represented with the symbol sigma. In statistics, you would have learned the sigma, right? So both are Greek letters. So that's capital and the small. I don't remember which one is what, but they both are sigma only. So this is also sigma and the other is sigma. Similarly, if I take a volume and inside that volume, if the charge is distributed, then what do I write? I'll calculate the total volume. I'll write the total charge which is present within that volume. Then you will call it as, this distribution is called as volume charge distribution. But what is the name of this? It's called volume charge density, which is represented with the same symbol rho. Am I clear with this? Is this point clear? So next question is, I need to look at the units of it. What is it going to be here? It is going to be coulomb per meter. Here it is going to be coulomb per meter square. Here it is going to be coulomb per. It's simple. That's it. Not a big deal. Simply you take a charge where you are distributing depending on what dimension you are distributing. Basically it is 1 dimension, 2 dimension and 3 dimension. If you distribute it on one dimension, you call it as linear. If you distribute it on two dimension, you call it as surface. Three dimension, you call it as volume. Same logic, right? That's it. Can you make a note of it? You give charge to a metal wire. I want everybody to think and tell me the answer. I give you a thin rod. I'll give you two thin rods, where one of the rods is made of copper, one of the rods is made of plastic. You charge both these materials. In which one do you think you can hold the charge for a longer duration? Listen to me. So listen to this, everybody. Those who have not listened, listen. I gave you a copper rod. I gave you a plastic rod of same dimensions, same mass, same everything same. Okay. You give charge to a copper and you give to plastic. Which one will hold for a longer duration? Why? It will not leak to the surroundings. That is the reason why they gave a dielectric sphere. Only for a spherical shell it will not be there. Because for a shell it will sit on the surface. This dielectrics is a separate story which we'll learn in next chapter. I hope it is clear, no? Right. So as I told you, there are three more concepts left out now. What is it? I showed you the other slides. Gauss law and the applications of Gauss law. But in between there is one thing that, see, this I framed it. Okay. There is something that I framed as a flow chart. So what would have happened in your textbook is they would have spoken like how you need to derive for the three charges that are there. But I am saying I am concerned about whatever question is being given to you, how are you going to do it. So I gave some 7 steps which need to be followed. Okay. So for this, as I mentioned, you need to first have the clear understanding of, for you to apply this, you need to have a clear understanding of charge distribution. And the second thing is you need to have a clear cut understanding of electric flux. We discuss about flux, no? So in the next class what I will do is, first 10 to 15 minutes I will be discussing 2 important problems from your textbook. So have your textbook along with you. I'll discuss 2 examples on how to solve it using electric flux. Then we will go to the Gauss law concept and apply it. Okay, it's very simple. I hope you could understand till now, right? Is there any confusion? Is there any topic that is tough? You could understand, no? So yeah, the update is tomorrow, maximum by Monday, I will be completing this chapter. Monday, if not Tuesday, for your batch, right? So I am not in a hurry to rush the portions. First few chapters are important. If you understand this chapter, 5th is easy for me because I need not teach. Wherever electric field is there, you will replace with magnetic field. My job will be easy. That is why I am stressing this much. So I explained about torque here, right? Torque experienced by dipole placed in uniform electric field. What do you think will happen there? Torque experienced by dipole placed in uniform magnetic field. Same story. Instead of electric dipole moment, you will have magnetic dipole moment. Instead of electric field, you will have magnetic field. It's very simple, right? Similarly, the subsequent chapters will become very simple if this chapter's basic is good. So what I am trying to say is, tomorrow we'll have, next Monday, Tuesday. By Tuesday, maximum I will complete this, and after that you will have a test. So please be prepared with it. I am just informing you ahead. So after I complete the first chapter, you will have 10 days time to prepare. I'll have to have a look at how many of you have worked on the assignment. So assignments will be given every week. Work on it sincerely. If there is any doubt, I'm not sure how many of you know this. There is a number where you can actually drop your message. It is 6369210899. So if you have any doubt, right, you can take a screenshot and send it to this number. You need not wait.